Okay, it just started. So an entity is a real world object which has properties. Okay, so let me make mention, we are not for this part going to use Dr. Nerenda's notes. No, we will use my own notes. We will make no reference to Dr. Nerenda. So just to prepare for that, we will do this uh, in a way easy for you to understand. So an object is a real world entity with which has properties. Okay, so that entity, remember, an object is a real world entity. Okay, so this object can perform tasks. So tasks are performed by an object. For example, human. So a human is an object, which is a real world object. And this human has properties. These properties describes a human or an entity. For example, this property has a name, or this human being has properties. Those properties, we have the name of a human being, the color of the human being, the height of the human being, and so on. Then tasks are methods. Okay, tasks can be performed by an object. So these tasks are methods, and these methods, those methods that we've been learning about, those methods, what is a method? A method is ABCD, and every Java code has a main method. So a method, okay, take note of that. A method, because we didn't put here, now is the right time to go back into whatever we were discussing, so that we put all those in a single container. So a method, supposing you are writing, is a starting point of execution of a program. Method is a starting point. Without a method, your program cannot execute. So a method is a starting point of execution of your program. A method is a starting point of execution of a program, and it is denoted by opening and closing bracket. Wherever you find something like that, that's a method. So human being, real world object, which has the properties. Those properties gives more information about that human being. I'm sure you can relate from the point of database. Name, color, height, and so on. A method is a task. Without a task, okay, a human being can't do anything. Imagine there's a human being who has the name, color, and whatever. For this human being, okay, to be appreciated properly, this human being has to perform certain tasks. For example, what are you capable of doing? You are capable of walking, you are capable of running, you are capable of reading, you are capable of writing, you are capable of jumping, you are capable of sleeping. Of course, I think everybody is capable of sleeping, but not everybody is capable of running. We are capable of eating, and so on. So please, we have started object-oriented programming, and we'll just look at the terms for now. Okay, object. Term number one, reward entity, and this object has properties, and this property can perform tasks, and tasks are methods. Okay, and those methods are example those. Is that clear? Is that clear? Erica, is that clear? The definition of an entity?
Yes.
An entity is, just like here, a reward. Hold on, an object. We are defining an object. We are not in programming. So an object, just like here, is a reward entity, okay, with properties, and can perform tasks. Okay, reward object with properties and can perform tasks. So a task is a method. Is that clear? Is that clear?
Yes, sir.
Okay, good. Right, so we move on to the second concept, class. Okay, a class. For so long we've been talking about a class, a class, a class. So what is a class? Okay, so a class is a blueprint. An object follows. A class is a blueprint. An object follows. Of course, we'll talk more about what a blueprint is. A class is a blueprint. An object follows. So let us break this down now. When we say a blueprint, what do we mean? Have we heard the term blueprint before?
Yes.
Okay. So let us begin from there. Uh, when we heard about a blueprint or we read, what comes in our mind?
Sir, for me, I see.
Okay. Of course, we will not get anything away from you. Erica, what comes in your mind when we talk about a blueprint? Okay, so all of you are right. So a blueprint, uh, think about a car. So before a car is made, uh, before a car is made, what is going to happen first? They have to plan. Okay, they have to sit. Uh, they need to come up with a design. So this design of a car, um, it will be a 4 door, it will be a V12. If it's a Benz, for example, S class, um, maybe S650. What's this? Okay, so they have to design almost every aspect of this S680. I think there is 680 S class now. It should be V12 engine. The way I love me and Mercedes Benz, we are in love. So I hate noise. Okay, let me just pause a bit. These guys are making noise. They are passing. I'm sure you can. Okay, thank you for that. They have passed. Okay, so we're talking about Mercedes-Benz. So before Mercedes-Benz releases its new class, of course there are other classes. For example, one of the spectacular Mercedes-Benz is AMG. I think C63 and C63S. Um, a very nice machine. Me and Mercedes Benz hope I have one. Okay, so they have to come up with a design. So in this design, they'll make the measurements, the drawings, and set. This part will have this color, this will be the engine model, this will be what. So a blueprint speaks to originality. Okay, a blueprint speaks to originality. So when for example you talk about Tasakira time pano. Sorry. Yeah, so um so a blueprint speaks to an originality. So here, I hope you can see my cursor. So here is an object. Okay, so this object, which is a real world entity with properties and can perform tasks. So this is a car, and this car, which is an object, okay, with properties such as color, um, doors, and so on and so forth, it follows a certain standard. Okay, what standard does this car follow? Those standards are what we are calling blueprints. Okay, so classes consist of objects. Okay, classes, that originality is made of objects. Give me a minute. Okay, just give me a minute. Okay, so these classes are made up of objects. And for example, the examples of objects are students, for example, and those students have classes, and these classes are basically variables, and these properties are basically variables, and these properties are names and so on. Okay, so these are tasks that can be performed by those objects. Okay, the third concept is abstraction. Mm. Okay, so abstraction. Abstraction just means show only what is necessary, then hide the implementation. It means when people, for example, um, how the student information system run. Each time you want to print your transcript, you don't go to accommodation. And each time you go to apply for accommodation, you don't know how the processing is done. So there is a back end and the front end. So the back end is the business logic. So we don't know the business logic. Only the person who designed knows how the processing is done. Okay? So what we are saying what we are saying is hide the implementation, hide how the processing is done, hide the logic, but give us the essential part. Just give us what we need, how that is being processed, and how the implementation was done. We are not interested in that, because implementation, we can't afford getting to understand how the implementation is done. That is very, very complex. Ours is to just say, okay, if I need a transcript, let the transcript come. Basically, I don't know how that transcript is being generated and alike. That is not our concern. Does that make sense?
Yes, sir.
Okay, good. So the fourth is encapsulation. These terms are very, very important, because the next time we are going to just say, okay, now we dive deep into these terms. So with encapsulation, okay, encapsulation means binding variables and methods under or using a single entity. So what we mean is this: binding means bringing together the variables. Remember here, properties are variables, and these properties are names, the height, the color, and the like. Those are properties which are variables. So binding is bringing together variables, those properties and methods, okay, under a single entity. So if we have a class here, okay, remember a class is a real-world object. So a class is a blueprint, okay, that an object follow, and classes are made up of objects, and an object is a real-world entity. So we have a class here. That class has what we are calling a student. Okay, so that student has the name. So the name, okay, so we have a student here, and that student has the name, the role that student can perform, the number, for example, the student number, date of birth. Okay, so we are saying, first of all, we can this is the method here. We can read, okay, we can play, we can write. Remember, a method is a task. So what tasks does this student can perform? This student can read, okay, and the task is a method. So we have that opening and closing, opening and closing, opening and closing. So that student can perform, can read, can play, can write, and so on. So we have variables, and those variables are properties. Okay, let me take you back here. So properties are basically variables, and these variables are names and so on and so forth. Okay, so names, heights, and the like. So we have the name, which is a variable. Okay, so bringing the properties, okay, which are variables, and the methods. So we have the methods here, we have properties here under the same or a single entity. That is what we are calling encapsulation. So binding variables and methods under or using a single entity. That is encapsulation. Does that make sense? Okay, good. The fourth, I think this should have been the fourth. One, two, three, four. The fourth is inheritance. The fourth is inheritance. So every one of us inherit. Every one of us inherit. So, for example, for you to be identified as a daughter too, it means you inherited uh, um, aspects, traits. For example, DNA. Okay, for you to be identified as, so inheritance is basically passing. So there there are those aspects of life that we get from lots of people. For example, you can inherit wealth. Someone can inherit poverty. Even poverty is inheritable. The DNA, and so on. Okay, so taking or acquiring the properties of another class, okay, or transferring properties of one class to another, that is inheritance. Mklasi iwe soma mlida leka nili mklasi iwe kagero leshupa nili mklasi endekeza. So inheritance is acquiring properties of another class to another class. So there are two classes here. So there is class 1, class 2, then we are taking the properties. Okay, what are those properties? Let's get back there. So properties are, for example, names. Okay, so we get, for example, you have a surname, and that surname comes from the male parent. So that is a property or a variable which was transferred from the father to a daughter. That is inheritance. So, so we are dealing with concepts such as, so we have the parent class. So please take note of this. There are three terms that we use under inheritance. Okay, so for an inheritance to take place, there must be the order and the latter. There must be an order and the latter. So the order is the parent, the latter is a child. So we have the parent and a child. And always, not sometimes, always a parent passes those properties to a child. Now, a parent class is also called a base class. it is also called super class. Okay. Um, there are times we are going to be talking about super keyword, this keyword. There are those times we're going to look at that in future. So whenever we come to speak about the super, we are just saying it is a parent. Okay. So parent class, child class, base class, derived class. Okay, so derived. Okay, remember in your in your um, in your database, derived, we are saying it is calculated. It can't be explicitly stored. So you have date of birth, then you want to find years. So a year is derived from. Okay, so you also have in science what we are calling SI units and derived units. For example, you have meters, you have grams, and when you get meters per gram, or you have kilometers, then you have kgs, then you say kilometer per kg. Okay, you have mass and so on. So mass um, uh, um, mass SI units. Okay, that is a standard SI. Haven't I even forgotten what I stands for? I've forgotten. But S is a standard. I've forgotten what I stands for. So you have SI units, the original. Then there are those, based on these originals, you can combine them, makes derived. So base class goes hand in hand with derived class. Super class goes hand in hand with sub class. Okay? Now, can I confirm with you? Is that clear? Okay, good. So there are types of inheritance.
Sir,
Please go ahead.
um, so you're saying about you mentioned about like it goes
Yes. 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 So when you use parent, use child. When you use base, use derived. When you use super, use sub. So there are types of inheritance. So there are what we are calling single inheritance. Okay. So this is a situation where there is only a single parent, like here. There's just a single parent, there's a single child. So a single parent passed its properties to a single child. That is single inheritance. There is also multi-level inheritance. Okay, so multi-level, I repeated multi-level, multi-level. Okay, I have to correct this. I have to correct this. Why did I repeat multi-level? Just give me a minute. Okay, so please, you can correct this. I think that's the reason uh, we we are doing this. Okay. My bad, my bad, my bad. So there's single inheritance, of course, um, just like we said. Okay. Okay. So I hope you are writing single inheritance. Okay. This is when one child class inherit from one parent class. One child class inherit from one parent class. Okay. Then, of course, we'll give details later. Then multi-level inheritance. Okay. So multi-level inheritance. I think the best example before we describe what it is what the best example that we can use. Just give me a minute. Okay, thank you for that. So the best example that we can use when it comes to my multi-level inheritance is um, in real life, we would look at our genealogy, like our ancestors. So, would give an example. I have mom. Mom came from her mom and dad. Um, then her mother came from her mom and dad. So you would find that there are those just properties. Even when we don't know what, we never knew what these guys looked like. They would say, Iwe. For example, if you sneeze some type of way, someone would say, you sneeze like. Okay? Um, but who is that? No, you can't know them, they died. So it's a situation where, if you can see my cursor, there is A here. Just first confirm. Can you see my cursor?
Yes.
Okay, so there is A here. Okay, then there is B here, then there is C there. So B points, C points to B and B points to A. Maybe there is D here, so D points to C, C points to B, and B points to A there. So you would find that A is a D is a child of C, and C is a parent of D, but this C is a child to B, and B is a parent to C. Now you'd find that B is a grandparent to D here. A is the overall parent. A is the overall parent. Okay, so A is a grandparent to D, but is a grandparent to C. It is a parent to B. So there is that. Okay, so D, the immediate parent of D is C. The immediate parent of C is B, and immediate parent of B is A. That is multi-level. They are levels, multi-levels. That's the type of inheritance of multi-levels. So by definition, first, before we define, do we understand that? Have we? Yes, in terms of family tree, yes. Okay, so by definition, so we can write by definition, so one class inherit from another, one class inherit from another, which inherit from another, which also inherit from another. That is multi-level inheritance. When one class inherit from another, which inherit from another, which also inherit from another, is called multi-level inheritance. So there are basically three, only that we repeated that. The other type of inheritance, first let me confirm, have we finished that? So the other type of inheritance is called hierarchical. H-I-E, H-I-E, R-A-R, H-I-E, R-A-R, C-H-I, H-I-E, R-A-R, C-H-I, C-A-L. Hierarchical inheritance.
So it's
Hierarchy, yes. Yes. But it is called hierarchical inheritance. Have we written that? Okay. So I want you to look at my cursor. Can you see my cursor? Okay. So there is A here. Okay, so there is A here. Just give me a minute. Okay, can you see my sorry about that. So hierarchical inheritance. So assume there is A here. Okay. Now there is A here. This A come down like that. Then there's left branch and right branch. So there is, for example, B here, C here. Let me take you back to multi-level. Multi-level, we had A here, B here, C here, D here. So in terms of family tree, D is related to C directly, C is related to B directly, B is related to, please go ahead. Yes. Did I agree to the first one of a family tree? Oh, okay, yeah. That is a very best way of looking at it. So multi-level is ladder, like. So you'd find that D is related to B, B is related to D is related to C, C is related to B, B is related to A. Indirectly, 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 D is related to B, and D is related to A through those guys in between. That's the best way of looking at it, ladder. Then, if you can remember your genetics, so we're branching off like that. Okay, so there is A here, there is B here, there is C here. So you would find that um, between B and C, there is no direct connection. So there is a direct connection between B and A, and between C and A, but not between B and C. That is the way of looking at hierarchical inheritance. So B can acquire the properties of A, but it can't have the properties of C. So let's look at this. There is myself and my sibling. So we both acquire the properties of the same parents, but I won't have the properties of my sibling, and the sibling won't acquire the properties of me. So I won't acquire the properties of my sibling, and my sibling won't acquire the properties of me, because both of us are at the same level. We are all children of that. Okay, that is hierarchical inheritance. So one parent class has multiple child classes. If you are writing, when one parent class has multiple child classes, is called hierarchical inheritance. Or when one parent class passes its properties to multiple child classes, that is called hierarchical inheritance. Are we good there? Oh, okay. We thought it is gonna be short, huh? We underestimated four pages, huh? But it's important to have a strong foundation. Okay, good. So it is also worth noting. So just note Two child classes cannot inherit properties of each other. That is very important. They can't, no, under no circumstance. Okay, so now we look at polymorphism. Please go ahead. Okay. Two properties of each other at no cost. So now we look at polymorphism. We look at the polymorphism. Are we ready? Okay. Before so poly means many. Okay. Morph, okay, means body. So just it's a smart way of saying uh, it's a smart way of saying one name, many forms. One man, one one name can exist in many forms. Before we define, so before we basically define, okay, let us start with a definition first. So polymorphism, are you writing? So polymorphism is the ability of an object is the ability of an object. Polymorphism is the ability of an object, comma, method, comma, ability of an object, comma, method, comma, or operator to take many forms. Good example. Please go ahead. Yes. So just like we are saying, poly here means many. Morph means form, many forms. Okay? So performing the same task in different way. That is polymorphism. For example, We've heard of a polygon, not so? What is a polygon? Okay, that is very much true. Okay, any sided shape, n. So it can have two, it can have infinite. And the infinite sided shape is called what? A shape with an infinite side is called what? A circle. That's a circle. Okay, so this this polygon can be a triangle. It means it has three sides. It can be a square. It can be a rectangle. So there is a square, rectangle, triangle. All these are polygons, not so? So we can draw a polygon. So we draw a polygon, but what type of polygon? So this polygon is just the n-sided shape. So, or a figure with uh, uh, multiple sides. Okay. So, um, we can decide to implement the square, uh, um, the rectangle, and so on. Same task, different ways. Of course, there is also an interface. Okay. Um, okay. An interface is a way of achieving multiple inheritance. So you have, of course, I was not supposed to put this in there. I don't know why. Okay, because these are the terms that we are going to be dealing with. Then it's just about combining those and looking at new terms as the result of combination. So there is a single inheritance here. If we put another guy here, it will become multi-level inheritance. There is a hierarchical inheritance here, and so on. Possibly we can look at. We are not going to look at those codes, I'm sure. Let us just end here so that um, we just look at those terms. We just look at those terms and end there. I don't know. It's not my wish to put these in the PDF. I didn't even realize that because this is a work altogether, we have to explain what is going on here and putting those in practice. So unless you have a question, do you have a question? So let us just end there so that the next time we start right from inheritance, interface, we explain what interface is, we look at the codes, then we dive in these one by one. Are we good? No question. Okay. Right. If we don't have a question, we are free to sign out. Of course, see you on Wednesday. We look at the database. Of course, we have to wait. We have to wait for being guided so that we know the way forward. And we're gonna discuss this right in the group in form of chatting. I hope the introduction of those terms makes sense to you. Does it make sense to you? Okay, good. I hope we've made the difference as compared to how they were taught in the actual lecture. Okay, good. All right, take care. Have a pleasant evening and see you on Wednesday, God willing.